Hey everybody, welcome back to Chapter 3, Section 2. Here I'm going over characteristics of quadratic functions, but they are in intercept form. So let's talk about what intercept form is. This is what intercept form will look like, where it's a times x minus p and x minus q. So in the last video we had an a on the outside of parentheses, but there was only one set of parentheses and it was squared. That was the vertex form, right? So in intercept form you don't even see the power of 2, but you have the presence of two x's here. So that's how you know it'll still be a quadratic equation. Your p, however, and your q, those are your x-intercepts. So your p and your q would be your x-intercepts, so they'd be written p comma 0, q comma 0, whatever they are. So notice how they are subtracting to begin with. You'll basically, whatever the number is given to you in the equation, you're technically given the intercepts. You would just need to flip the signs on those. So here I have -2, 0, and 4, 0. So that means I know my p and I know my q. So my p is -2 and my q is 4, right? So when you look at the equation, if p is a negative number, what happens when you subtract a negative number? You plus it. And then if q is a positive number, it'll just get plugged in. So if it's default minus, it's negative. So yeah, I did write this out of order technically, but it doesn't really matter which one goes first, the p or the q. I like to read it from left to right, so I'm like, hey, this is p, this is q. So I guess when you would write it, I should have written the x plus 2 first and then the x minus 4, but it's not that big of a deal. But that's your p and the q. So if you want to calculate your vertex by hand, you'll need to calculate the axis of symmetry first. Just like we did in the last video, we calculated the axis of symmetry first, but it's a different formula. You use the p and the q, and you divide it by 2 because the vertex is halfway in between the x-intercepts. Once you get that, then you would plug that in to find your y value, and then you know where your vertex is. So, like I said, this is called intercept form. The equation itself will tell you your intercepts. Like this tells me that one intercept is at 4 comma 0 and another one's at -2 comma 0, since it's x minus p, x minus q. So if you really need help following these steps in the calculator right here, menu 6, analyze graph, and then 0, that'll tell you your x-intercepts, because x-intercept is synonymous with 0 and roots and solutions. You see all those words used for the same thing. So now that all that's out of the way, let's just do some examples. I'm giving you this function, identify the following information. So I know that any quadratic equation, no matter what form it's in, is all real numbers for the domain. So you can write it with the all real numbers symbol. You can put negative infinity to positive infinity. Just make sure both are in parentheses. Now, the range, we don't know quite yet, but we do know our x-intercepts. It says x minus 6, x minus 2. So that means my x-intercepts are at 6, 0, and 2, 0. So if you want to think of it as just flipping the sign, sure, just flip the sign from the equation, but not from the graph. Like I didn't say p was positive 2 here, it said p was -2 to relate it back to that. So my x-intercepts are at 6, 0, 2, 0. And then the other thing I know without doing any work is it a max or a min? And that's because that front number was -1/2. That's your a. So if a, this is straight from the last video. So if a is negative, that means your graph opens down. And if your graph opens down, that means your vertex is the highest point. So your vertex is at a maximum. All right? Now the rest we'll need to do a little bit of work here. So I need to calculate my axis of symmetry if I'm going to figure out the vertex, because the vertex can tell me my maximum value, my axis of symmetry, the vertex, of course. And then once I know that, I'll know my range. So I'm going to do x equals p plus q over 2. So x equals p is 6, q was 2 over 2. So that is x equals 8 over 2. That's x equals 4. Now that I know my axis of symmetry, I know my x value of my vertex. So I have x equals 4 here, and then 4 comma something. So I just need to figure out the y coordinate of my vertex. So just plug in 4 into your function. So I'm going to do f of 4 equals negative 1/2 times 4 minus 6, and then 4 minus 2. And so doing that will give you your y value. So, I made a mistake. I wrote f of x. If you're plugging in a number, don't write f of x, write f of the number you're plugging in, so f of 4. Small detail, but just thought I'd point it out. So remember, that tells you your y value. This will be 2. Negative 1/2 times 4 minus 6. That's negative 1/2 times negative 2, so that's positive 1. What's positive 1 times 4 minus 2? That's 2. So y equals 2. So when you know your max min value, you know your range will be y is less than or equal to 2 or greater than or equal to 2. I'll fill that out in a second, but I want to make sure I write the rest down. Y equals 2 here, and then my vertex is at 4 comma 2. Okay, so since we determined that it's a maximum, because the graph's going down, because a was negative, since a was negative, you say less than or equal to 2. Or you can write it as negative infinity in parentheses, 2 in a bracket. But yeah, that's everything to say about number 1, okay? So number 2, I give you this graph right here. And then I ask you all the same questions, except at the very end I say, what's the function? So the graph alone tells me everything except for the function, like right out of the bat. And then plugging it into our intercept form, we'll be able to, plugging in numbers into our intercept form, we'll be able to figure out the function. So let's label everything we know right now. We know that this is my vertex, and we know that this is your P and this is your Q. Those are your x-intercepts. And I know that this is my AOS. So I'm going to transfer that information over to the blanks. Okay, so the domain, always all real numbers. My axis of symmetry was given to me, x equals negative 1. The vertex was the very topmost point of the graph. That was at negative 1 comma 8. So the graph was opening down, so I did my range as y is less than or equal to 8. And that min-max value is just y equals 8. That was using the vertex. I wrote negative infinity to positive infinity because, I don't know, I'm used to writing that. If you wrote the less than or equal to 8 in the other form, you'd have negative infinity first and then positive 8 in a bracket second. My x-intercepts, where did it touch to the x-axis? Negative 3, 0, and then 1, 0. And then the graph was opening down, so I know it's at a max. So that's everything the graph was telling me, right? So I need to figure out the function. That means I need to plug in what I know to this, okay? So I'm going to plug in my P and my Q, and then I'm going to end up plugging in a point for my X and my Y, and I'll figure out the A. So let's see what that's going to look like. So if it's X minus P times X minus Q, my x-intercepts were negative 3 and 1, right? So x minus negative 3 is x plus 3. You're flipping the sign when you plug it into the function, if you want to think of it like that. And then it's, since it was a positive 1, it's x minus 1, all right, for the q part. So what you do now is take any third point and plug it in for x and y. So any third point meaning any point that's not p and q. So I could use this vertex point, I could use this point right here. Any point that you can identify on the graph, you can use. So just to show you what I mean, let's just use this first point I did in red. that looks like that's at -2, +6. So I'm going to use that for x and y, all right? So I'll label it x comma y. So I'm going to plug in 6 for y and -2 for x. So I'm going to say 6 equals a, and then I'm plugging in -2 for x, so -2 plus 3 times -2 minus 1. All right, so that's everything plugged in. So let's take it up here. What's -2 plus 3? That's 1. So 6 equals a times 1. And then what is -2 minus 1? That's -3. So -3. What is 1 times -3? That's -3. So 6 equals -3a. We'll write it with the letter coming second now. And so just divide. What's 6 divided by -3? That would be -2. Now that we know a is -2, we just throw it into the very first part, which was right here. Because when we set it up, we knew the very first part was right here, sorry. We knew that we knew our P and Q. You just need to know your A. So when you write your function, you don't plug anything else except for the P, Q, and A. So f of x equals -2 times x plus 3, and then x minus 1. And that would be your function. If you're going to check your work in the calculator, you would have to plug in your function and then do Control-T to find the table, and the points that were given to you, you would have to find in the table. So I'd look for -2, 6 in the table, -1, 8, -3, 0, 1, 0. I'd look for all those points. And if I saw those, then I know I did it right. So the last one, I'm giving you 3, 0, 8, -6, and 6, 0. And I'm asking you what's the equation that runs through the points, and then what's the vertex. Okay, so remember, if I'm giving you a number, comma 0, I'm giving you an x-intercept. So this is my P and Q, the ones with a number, comma 0. All right. This third point, I don't know if it's the vertex or not. I'll just label it as x, comma y. So I know my P and my Q, and so looking back to what we did here, the first thing I did was plug in my P and my Q, and then I plugged in an x and a y. So since we already know that, let's just jump right to, well, I'll do the red part first too, just to have this set up. So what I was saying is you can kind of just jump right to this step in blue, plug in everything you know. But I find that it helps just to write the P and Q first off, because people will mess up the function at the end when they don't do that. So anyway, what is 8 minus 3? That's 5. What is 8 minus 6? That's 2. And so it's equal to -6, because I plugged in 8 for x and -6 for y. So what's 5 times 2? That's 10. So I have -6 equals 10a. So I'm going to get a fraction for a, right? So I need to divide out 10. And so it looks like a is going to equal -6 over 10. That would simplify to -3 over 5. All right? So once you know that, throw it in there. So we know our function is now f of x times -3 over 5 times x minus 3 times x minus 6. Once you have your function, then you have to do what we did first to figure out the vertex. The very first example was use that p plus q over 2, and then figure out your x equals your axis of symmetry, and then figure out the y. So let's do that right now. I know my P and Q are 3 and 6. So my axis of symmetry is just what is x equals, what is 3 plus 6 over 2. 3 plus 6 is 9. 9 over 2 is 4.5. So you can leave it as a fraction, x equals 9 over 2, or you can give it to me as a decimal, 4.5. It's probably a little easier to do it as a decimal. So then just plug in 4.5 into the function. So f of 4.5 equals, and so I'm going to do negative 3 over 5, parentheses, and then 4.5 minus 3, 4.5 minus 6, and then we just need to type that into our calculator to figure out our y value. So when I plugged it into my calculator, I got 1.35, which means my vertex will be at 4.5 comma 1.35. So now I've answered all the questions. I got the vertex, I got my equation, and I got my vertex, and I did it all by hand. So at this point, we've done a lot of work by hand. If you want to check your work, look at the graphing calculator. Can you find those points on the graph? So here I graphed it on the Desmos app, and then I went to the table and I saw everything we were given: 3 0, 6 0, 8 negative 6 is there, 4.5, 1.35 for the vertex. That's all there. So that's how you would ultimately know if you did it right or wrong. So thank you for watching. Goodbye.